All right, today we're going to look at velocity versus time graphs. And what a velocity versus time graph does is exactly that. It tells us what the velocity is over time. So for instance, here I start out with a positive velocity. It stays positive, then it starts to become a smaller and smaller number, and then my velocity becomes a negative number. So it's telling me what the velocity is at any given moment in time. Now there's some more information we can pull from that. The intercept of the graph tells me about the initial velocity. So what is the velocity at t equals 0? Okay. The slope tells me about the acceleration. Now the steepness of the slope tells me how big that acceleration is or small it is. And if the slope is positive or negative tells me about the direction of the acceleration. Now remember, a negative acceleration doesn't necessarily mean it's slowing down, it's just telling you the direction of that acceleration. The area under the curve on a velocity versus time graph tells me about the displacement. How far has it gone and in which direction? So the size tells me about the magnitude for the area under the curve. And I'm going to show you what that looks like on this graph here. And if it's above the axis or below the axis, tells me about the direction of that displacement. Now, there are some other cool things we can get about speeding up and slowing down that are a little different than we just have to look for velocity, acceleration, same direction speeding up, opposite direction slowing down, acceleration of 0, constant velocity. So from a velocity versus time graph standpoint, it's speeding up if the graph is moving away from the axes. It's slowing down if it's moving toward the axes, and it's a constant velocity if it's parallel to the axis. So let's go ahead and look at that on a graph. So at this moment here, the velocity is a constant number. It's staying at this height the whole time. And it's parallel to the axis, so yes, I am moving at a constant velocity. Here, I'm going down. My velocity is getting smaller, and yes, I'm going toward the axis. Now, what was the other way we used? We said, oh, velocity, acceleration have to have opposite directions for it to be in slowing down. So I'm on this side of my graph, so it's a positive velocity, but the slope is negative. So I have a negative acceleration, positive velocity. Yes, it's slowing down. And at this point, my velocity is 0. And what's happened here is I went from a positive velocity to a negative velocity. And what does that mean if you go from a positive velocity to now a negative velocity? It means you've changed directions. You've stopped moving in the positive direction. Now you're moving in the negative direction. And so now my velocity is negative. My acceleration is still negative because the slope is negative. So I'm speeding up, and you see that, yes, we are moving away from that axis. So we can use this velocity versus time graph pretty neatly to determine if it's speeding up, slowing down, or at a constant velocity. And again, that constant velocity one, we have that parallel where the slope is 0 or the acceleration is 0. Okay. So the last one we're going to look at is the area under the curve. And so I was going to show you what do I mean by area above the axes and area below the axes. So above the axis would be this area here. So this would qualify as a positive displacement. Okay? And that's because I was moving in the positive direction for a certain amount of time, so I would have had a positive displacement. Now, over here, I'm moving in the negative direction for an amount of time, and so this area over here would correspond to a negative displacement. And if you wanted to then figure out the overall displacement, you would just have to add this and then add this, but it would be a negative number, so it would be like subtracting that area to get the overall displacement. And so this is how you use velocity versus time graphs.